Alright, let's look at the homework 7.6, problem number 7. Alright, so let's do this. Alright, so we want to maximize the volume. Volume is x times y times z. And the constraint is so the length plus girth. So length would be, let's say, x. And the girth would be 2y plus 2z. And it has to be equal to 114. Alright, so let's do that. Alright, so let's come up with f, right? Capital F is going to be x, y, z minus lambda times, right? So I'm gonna actually rewrite it this way. So I'm gonna just subtract 114 from both sides, so that you have x plus 2y plus 2z minus 114 is equal to 0. Right? So we have x plus 2y plus 2z minus 114. Right? So let's take the partial derivatives. So partial with respect to x would be yz, and then let's see, negative lambda, and set that equal to 0. You have that. Right? So this tells you that yz must be lambda. Right? And partial with respect to y would be xz, and a minus partial with respect to y, so it's going to be minus 2 lambda. So set that equal to 0. You're going to get xz is actually equal to 2 lambda, right? And the partial with respect to z would be xy and a minus 2 lambda, right? And is equal to 0. And this is just going to be xy is equal to 2 lambda. Alright, then partial with respect to lambda would be negative x plus 2y plus 2z minus 114, right, is equal to 0. Alright, so what I'm going to do is, first thing is I'm going to actually multiply by negative 1 so that I can get rid of the negative sign. So x plus 2y plus 2z is actually I'm going to actually add 114 there, is equal to 114 on the right hand side. Alright, then what we're going to do is I'm going to start solving. So let's see, I'm going to solve this equation for, say, y. So divide through by z. So y is equal to lambda over z. Right? So if you divide this equation by z, you get x is equal to 2 lambda over z, which means that the same thing as 2y. Alright, so x is actually twice as big as y, right? And if you combine the last two equations, you can see that both of them gives you 2 lambda. So combining these two, we know that xz must be equal to xy. And divide through by x, assuming that x and x is not equal to 0, you get that z equals y. Alright, so x is twice as big as y, but the z is the same as y. Right? So we can do this. Right? X is 2y, and y is the same. Let's see. So 2y is 2y. Right? Z is same as y, so it's going to be 2y is equal to, so that's 6y, right? So that has to be equal to 114. Right? Then if you divide through by 6, so y is equal to, that's going to be 119, right? So we have 19. Right, so once you know that y is 19, and we know that x is twice as big, so x is 38, y is 19, and z is the same as y, right? So let's check the answer, right? So we got 38, comma, 19, comma, 19, right? Let's check the answer. Submit for testing. All right, I came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.